Working through question 12 on page 342, in section 7.3, we're asked to draw 4 rectangles with these dimensions 3, 4, 6, 8, 9, 12, and 12 and 15. And comparing them, the first part of the question asks which rectangle is not similar to the other rectangles. To do this, to figure this out, we can use scale factor, which is diagram over the original. So if I take this one as the original, I can take 6 over 3 and 8 over 4 and see if they're equal. 6 over 3 is 2, 8 over 4 is 2. So these are equal, so that means these two rectangles are going to be equal. I could also take 9 over 3 and 12 over 4. And we see that 9 over 3 is 3, 12 over 4 is also 3. So we have similar rectangles. Since these 1 and 3 are the same, that means 2 and 3 are also the same. I can take now 12 over 3 and 15 over 3. 12 over 3 is 4, 15 over 3 is 3.75, and we can see that these are not equal. So that means this rectangle is the odd one out. So rectangle 4 is not similar to 1, 2, or 3. The next part of the question says draw 2 different rectangles that are similar to the rectangle to this one here. So if we take a scale factor, we can choose any scale factor we want. Scale factor, if I say I want that to be 2, I would take my each dimension, so 12, multiply that by 2, we get 24, and then 15, multiply that by 2, I get 24, or sorry, I get 30. And so a rectangle with dimensions of 24 and 30 is going to be similar to that rectangle there. I can also use a scale factor that makes it smaller. So 12 and 15 both divisible by 3. So if I want to have a scale factor of 1/3, I would go 12 times 1/3 is equal to 4, and 15 times 1/3 is equal to 5. So a rectangle with dimensions 4 and 5 would also be similar to this rectangle here. Part B says the diagonal of the smallest rectangle has a length of 5 units. So we're looking at this right here. This diagonal is 5 units. Use proportions to calculate the length of the diagonals of the other 2 rectangles. So I want to know what the diagonal is between this one here and this one here. So if I use proportions, this is what we did up here. I would take my unknown. So if I take this one here is my unknown, I would call that diagonal x. I'm going to call that diagonal y. So using proportions, I want what I want on the top. So x over 5, because that's the similar side length, that should be equal to 6 over 3, because that's a similar side length there. So when I use proportions like this, I can solve for x. I can multiply by 5. I can figure it out, reduce there. I have x is equal to 10. So the diagonal on that rectangle is 10. I do the same thing here. Y over 5 is equal to 9 over 3. And so again, multiply by 5, and I end up with y is equal to 15 here. So this is how we're using proportions. When we set up proportions, what we want over what we have, and then using a full proportion that we already have there.